Welcome to the channel DevOps with Dipesh, and in this episode we are going to design a pod. If you see a pod, there are a lot of things in a pod. There is the labels, annotations, config maps, environment variables, secrets, then you have resources where you define the limits and requests. Then there is the health check of a pod wherein you have liveness probe, readiness probe, and all that. But because there are so many things, in order to design a pod, you have to start with something basic. Like if you want to build a tall building, then you have to start with the base of the building. Similarly, in the case of a pod, what we need to do is we need to start with the very basic pod which has minimum configuration. I call that pod a skeleton pod. So let us start creating a skeleton pod. So I do this in namespace dipz22ns run. The name of the pod, it is dipz22py and image. I'm using the same image that I have shown you in my previous video how I created this image. It is from Alpine, and I have my own entry point and CMD defined in this image, which prints out 1 2 3 4 number. So you can check my previous video for checking how I made this image. So we use this image which was pushed into Docker Hub. Dipesh M77 Alpine :1 Alpine :1. So this is the image we are going to use. And restart never, that means that it is a pod and it is not a deployment. Now we will put the labels. Environment variables, then requests. I am requesting 200 CPU is equal to 200 M, memory is equal to 256 semi, then limits CPU is equal to, it will be slightly higher, it can be same also, but I am keeping it slightly higher. 500 M memory is equal to 512 M. I think I wanted to put it 256 instead of 356. That's a typo. Yeah, so this is my skeleton pod. So I have specified all the things that are mentioned over here. It has the label, it has the environment variables, var1 is equal to value 1, var2 is equal to value 2, and these limits and requests. You can see the limits, the requests, and the environment variables over here, and the labels are over here. So let us now do a dry run to check that this is a good syntax. Yeah, it is perfectly fine, and I generate the YAML configuration and put it inside a file pod.yaml dips22py-pod.yaml. So that's it. Now I want to create this particular pod to check if the pod is getting created or not. Create -f dips22. Yeah, the pod got created. Let me check if it is running. It is also running, and I can check the environment variables that I let it print the environment variables. So variable 1 variable is value 1, variable 2 is value 2. The environment variables are getting printed, so everything is fine. I'll delete the pod. I do a force deletion. Okay, so because I don't want to wait, because it takes some time for the pod to get deleted. I don't want to wait. That's why I'm doing a forced deletion over here. Okay, so my the skeleton pod is ready. The YAML file is ready. I can create it anytime. Then uh, if we see there is a problem with this skeleton pod, there's a weak link. That is basically because the main process starts as root, but I want, from security perspective, it should have little bit more security, so that the main process should start as a different user other than root. I will name that user something like 1000, and basically I will configure the user and the group. And how you do that, that is something called security context. Security context is nothing but a protection. So from the security perspective, your pod is very nicely protected, because you do not use the root user, which is running the main process. The PID is equal to one process. And so we will define that. We will see how we create security context in this pod. So we go back to our YAML file, and right here, just above container, you can security context. Sorry, it is case sensitive, so we have to be mindful of the case. Security context, which is run as user. I give 1000 is the user that will run it, is not the root user, and run as group, which is like 3000. And I also add fs group. The reason I add this fs group as 2000 is that if some path is mounted, I want that the group of that particular path should be 2000 and not the root group. Basically, I am changing the ownership of the process as well as the mounted path, the group ownership, and the process, the user ownership as well as the group ownership. So let's see how it whether it works or not. And we are going to, okay, I have saved the configuration. So basically the main process PID is equal to 1, that should be user 1000 and group 3000. Any directory mounted should not be default root group. For this, use fs group in pod security context. Container level security context will always override pod level security context. So you can also define the security context, like I will show you again. So here, if you see the security context over here, I am defining it is in the pod level. But if I define the same security context inside the container, so just above resources, if I write something like security context over here, security context, so there can be two security context as well, and they might, what can happen is, if I say run as user something like 6000, for example, some other user I am putting over here, so they will conflict. So how the conflict resolution takes place, it is always the container level security context which overrides the pod level security context. So just keep that in mind. Right now we will just delete this, because we are not using the container level security context, we are using the pod level security context. That is just for your information. So we go back to this thing and we create the pod out of it. Okay, the pod has been created. I want to enter the pod exec minus it dips22py and then sh shell, and I have entered the pod. So if I do a ps minus ef, you can see that this is the process, this is the PID1 process, and it belongs to user 1000 and it doesn't belong to user, so that's good. So our security context is in effect. So I delete the pod now, and then go to the next topic. The next topic is, now I want to define the config map. So now what is config map? Config maps are useful for storing and sharing non-sensitive unencrypted configuration information. Advantage is that it prevents hard coding data into pod specifications. So there can be so much of information, like the pod connects to a database, to a particular database string or a database name, and also on a particular specific port. Excuse me. On a particular specific port. So all those information can be captured in the config map. The advantage is that it of course doesn't allow, it also of course prevents you from hard coding data into port specification. Okay, so let us create the config map. So first we will create cm1, then cm2, then cm3. 22 ns create cm1 from literal you have to provide is equal to, what is that? Let me try to reduce this like this so that I can see. From a literal var 3 is equal to value 3, then just copy this. From literal var 4 is equal to value 4. So my first config map has been created. The second config map I want to create, second config map will be from literal db is equal to mysql dips 22, mysql dips 22, and from literal port, I think it's the port which will be 3306. We are good. Okay, so this config map is cm2. This is second config map. I forgot to change that. Okay, so cm2 is created. Now I want to create cm3. Okay, cm3 from literal, just d dollar will clear everything from that point. From sleep time, so let me just lower it a bit. Sleep time is equal to 2. That's very good. Yeah, I saved it and I ran it, and config map cm3 is created. Now these three config maps have been created, all right, but then I need to consume it in the pod. So how do I do that? So I just go back to my YAML file. No, control. Okay, I go back to my YAML file. Here I have to inject the config map. So I start with cm1, which should be mounted as a volume in the path /etc/details. You can see over here. So what I do over the containers, I define volumes name cm1 volume. So this is local to the pod. I can give any name. I'm giving here cm1 volume. And what else? So at any point, if you are like struggling to find out like what is it, you can always do a kubectl explain. So kubectl explain is basically nothing but k explain pod.spec.containers dot where I'm stuck here, say for example volumes, it will tell me, okay, spec.containers. Why does it say that volumes? Okay, so it's spec.volumes actually. So it is in that container level. That's my mistake. So it will tell me, so what kind of volume I can give, secret, I can give so many things, RBD and all that. So here we are working with config, so there should be config map also somewhere. Let me see, persistent volume claim I can give volume. Where is secret? Config map I can see. Oh, I didn't see secret. Okay, secret will be like alphabetically, yeah, here. Yeah, So name this thing, and then secret I can give. But what is this secret? The secret should have a name, right? The secret should have a name, but I cannot give name here. It's just a trick. Like you have to give secret name over here, and then you have to give your. No. We are not working with secret. My mistake. So we are working with config map. So config map and the name of the config map. The name of the config, which is CM1. So that's fine. And now I need a volume mount for that. Volume mount will be just above image. So I do a shift O, and yeah, volume mounts. Similarly, I need a name over here. What is this name? The name is the same, CM1 volume, and I need mount path. Mount path is /etc details. Yeah, that's good. So CM1 has been injected. Now I'm going to inject quickly CM2 and CM3. CM2 is injected as environment from. So just above image, I can do a shift O and do a environment from, and environment from what environment from it will be? It will be a config map reference. Config map reference, and then which config map reference, that you have to provide the name. So the name will be CM2. So this is the second config map we are injecting. So this is good. So this is done. And then next is CM3. We need to inject CM3. CM3 has to be injected by the keyword value from, and so I'll show you how you can do that. From here, it is basically the same environment level you have to define. So you see name and value. So instead of value, it will be value from. So we'll copy these two lines to escape to YY capital P name. So what is it that we are going to inject? We are going to inject sleep time. Sleep time value from, not value. So value from. So here you have to provide name. Sorry, you have to provide like value from the config map key reference that you have to give, which is very important to know, because if we do not give the config map key reference over here, it will not be able to know from which key it has to import this particular value. So it will import only one, sleep time. So config map reference, and then name. Which config map? It is CM3. Which key? It is sleep time. So you can check it that this key name is the same as the environment variable name. We will check this environment variable is getting listed or not when we run the pod and we check the environment variable. So I just save it and I'm coming out of it. And now I want to create the pod. Create the pod. Yeah, this is the command. I have created the pod. Now I want to exit. Yeah, but I just want to check env, what are the environment variables, and here you can see sleep time is coming here. So it is getting correctly populated. The injection of the variable is working fine. I will not check the other two, but I am just hoping that they are all fine, and they should be fine. 99% I am sure they are working fine. So we will go ahead. We have now injected these three config maps. Now we will go ahead to the next topic. Yeah, but before going to the next topic, I just let you know that these config maps, when you are changing the values of the config maps, it is not that immediately the value will be reflected at the pod level. So the total delay from the moment when the config map is updated to the moment when new keys are projected to the pod can be as long as kubelet sync period plus TTL of config maps cache. It's just something that you should know. it's not, otherwise it's not that important. So we move on to the next topic, which is secrets. So we already have config maps. So what is like secrets? Why we need secrets? That is because secrets help to store sensitive data. It is safer and more flexible, as you don't have to store in pod YAML file, and it's base 64 encoded. Okay, it is like not a very high level protection, but at least it's a basic level protection. So you have base 64, so it is kind of some protection is there for your sensitive data. Say for example, API key, root password, application password, so these are sensitive data, so I put them in secret. So we'll create secret 1, secret 2, secret 3. Okay, so I just lift it up here a little bit. I start with create secret generic. You have to write this generic keyword, otherwise it will throw an error. Secret 1, first secret I'm creating, from literal is equal to API key is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just a random number, not a just some number I have given, for example. So this is done. Secret 1 is created. Now the secret 2 from literal is equal to root password is equal to 1089 underscore 15 $hash. Yeah. Oh no, sorry, I needed one more, so I'll just delete this. Delete secret 2, because I need to fc-1 will give me the other command that I just ran. So I can just do a www, so it helps me jump from, and here I can do a copy. How do you copy in vim? You can copy yi capital W, and so I copied this whole thing. So I go shift dollar and p means it copies. So here only it will be, the root will be changed by app. So app, that's it. So this is my secret 3. Oh, okay, this is my secret 2. Yeah. So the secret 2 got created. So k minus mdips 22 ns get secrets. It will give me secret 1 and secret 2. If I can get secret 2 minus YAML, it will tell me the same value for the root password and the application password, but these are different because these are base 64 encoded. So I want to check actual value. I will do this, and then I do a base 64 minus d decode. So it decodes, and this is the actual password. So I can also decode this encrypted password. Okay, now we have to create the secret 3. Okay, so just go Control E, Control W, secret 3 from literal is equal to access token is equal to 892472477777. Yeah. So secret 3 is created. Now similarly, I am going to inject these 3 secrets into the pod. So how I can do that, I'll just show you. So here, let me go back to the same YAML file. Oh, my caps lock is there, so that's why. Let me go to the same YAML file. So I need to first inject the secret 1. How do I inject it? And I have to inject it as volume secret 1. You can see here secret 1 will be injected as volume in the path etc secret. Secret 2 will be from environment from, and secret 3 from value from. Just like config map, these things will be injected, and this is pretty simple. So first what I do here, I copy 3 lines. So it is 3yy capital P, and it gives me these things. I don't have to type it again. What I am going to do is I am going to do secret one volume, and this is not config map, so this is secret. And yeah, here what is important is it will be secret name, not only name, and it is secret one. So this got injected here. Well, not really, because I have to give the volume mounts. So the volume mounts over here, and I'm going to copy two lines. So 2yy capital P, and then here it's not the CM1 volume, but it is the secret one volume, and I am injecting it in path etc secret. You can see from here it is etc secret. Yeah, and then the next is environment from, and next is values from. So environment from, if I go here you can see the config map reference environment from. So I have to copy these two lines. So it is 2yy capital P, and it's a config map reference, but I'm dealing with secrets now, so it is secret reference, and name is secret 2. Yeah, so that's all. I mean, that is as simple as that. And then the last is value from, and I have to inject the secret 3. Where is value from? Here it is, the value from over here. And 1 2 3 4 5 lines I will copy. 5, sorry, escape, 5yy capital P. That's it. So the name is not sleep time, but the name is access token this time. Access token, because if you see here, this secret is the last secret 3 is access token, and I have to inject this and access token. Therefore I have given the name access token. Well, I can give any other name, but for simplicity I'm giving access token name. It's not config map key reference, it is secret key reference, which is very important to know. Secret key reference. And what is the name? Name is secret 3. Secret 3. Okay. And what is the key? The key is access token, which matches the name of the environment variable. Yeah, this is fine. So I have injected all 3 secrets. Let me run create minus fdips. Does it run? Okay, there is some, okay, because I didn't delete this, so I have to delete the pod, then create it to check that everything is fine. Create, yes, yeah, the pod is getting created. And if I do logs, check the logs, yeah, everything is getting generated. It is generating 0 1 2 3, so things look good. I want to print the environment variables and see that the environment variables from the config map as well as secret, the access token and sleep time is getting populated or not. So exec, I have run the command. Let's see, take use of that. Yeah, sleep time, access token. Where is access token? Oh yeah, so both of them are here, so everything is fine. I delete this pod and I move on to the next. I delete the pod, move on to the next topic. So I have injected the config maps, I have injected the secrets. The next topic for me is, well, I don't know, well, I do not have to show you this because I think you already know, because due to the security context, the path slash etc details will be owned by group 2000, which I will again show you, but this is something which is already known. Then yes, then we give some task to the container. The container already has a task. It is printing 1 2 3 4, but we generally what we want to do, we want to give it a different task. So what it will do, it will generate on a random number from 1 to 6. So it's basically like rolling a die and putting the output in temp slash die underscore output.txt file. Let's see how we can do that. Well, we go back to the same YAML file. And here if we come down and just above resources we can do that shift O, it will create an empty line. What I can do here is command. I can do a command and I can give slash bin sh. So this is basically is going to overwrite the entry point of the container. Good to know that. This I specifically covered this topic of entry point args and then the entry point and command of the Docker versus the command and the arguments of the pod and how they are related. That is already covered in the previous video. Feel free to go and watch that video. I think it will clear a lot of your doubts. And okay, so coming back to this particular pod YAML, I have to put the arguments here -c, and what it is going to do, it is going to, while true, this is always true, and do shuf -i126 -n1, and it's just going to place it in /tmp/die output.txt, and then sleep for some time, which is defined in the sleep time variable which we created, if you remember, and then done. Yeah, basically that's it. So this is what it is going to do. I have already given some task to the pod and we'll see whether this works or not. I basically create one more time, create the pod. Pod is created and I just check the logs. Where are the logs? The logs are just not coming. Okay, the logs are not coming because I am not printing the logs. So let me print the logs. So let me just delete the pod. I'll just delete the pod and I go back to my YAML file. Here what I am doing is it is just putting the random generated value from 1 to 6 to the file temp die output.txt, but it is not printing them. For printing them, what I can do, I can do a cat/tmp/die output.txt. So that should be it. Then I can print the value. Let me run it again. Okay, and let me put the logs. Yes, so now it prints the random value from 1 to 6. So it is rolling the dice, it is waiting for 2 seconds, again rolling the dice, again waiting for 2 seconds, and actually putting the output in /tmp/die output.txt, this particular file, and it is showing me the value, and that is how the logs are getting generated. So this is all good. I have created all these things. I have created the security context, I have created the label, I have created CM config maps, 3 config maps, 2 environment variables, 3 secrets, and injected them, and I have assigned resources, and I have also given a work to the pod. So it's all is very looks very good. So let's go to the next topic. So the next topic is basically the heart of the or the health check of the pod. So we need to check whether the heart is beating or not, or it is dead. So that check, that is defined in the liveness probe and the readiness probe. So we will now create the liveness probe and the readiness probe for this pod. So we go back to our YAML file, and I'm just going to stop this. I'm just going to delete this pod and delete the pod, and I'm going to go back to my YAML file, and here just on top of image you can specify the liveness probe and the readiness probe. So it shift O will give me an empty line. Let me start writing liveness probe. What is the liveness probe? Basically, I'll come to that. Liveness probe is basically, it is something, it is a check for the pod. It needs to know, the kubelet of the pod needs to know if the pod is actually healthy or not. If the pod is not healthy, then what is the point in running the pod? So it needs to kill the pod or stop the pod. So that check is there in the liveness probe, and once the pod is stopped, it again the kubelet again starts it based on some other configuration, like like after how much second it needs to start and all that. So all this configuration will be put here, will be putting here. It is something called initial delay seconds, which specifies like after how many seconds we are going to start the liveness probe. Okay, so it's sometimes it happens the pod takes some times to come up. After that only the liveness probe should be checked. So you need to give some time for the pod, some breathing time for the top pod, and then only you should check whether the pod is healthy or not. So that initial delay seconds that you have to provide. So I am giving it how much I need to give. I am giving the breather of 30 seconds. Initial delay seconds will be 30, and then probe every 10 seconds. So it should not keep on probing like continuously, but after, you have to give a gap. So in this case the gap that I'm giving is 10 seconds, which is called period seconds. So after 10 seconds only it will do the next subsequent probe. Then consider that it is a failure, the probe is a failure, so the container can be stopped. Consider that it is a failure only after how many attempts? 4 attempts. So the default is 3 attempts. So this particular parameter is called failure threshold, which is 4. If I don't define, the default value is 3, but here I am defining. And then, but what is this liveness probe? What is it going to check? So it is going to check this thing. It is going to check cat temp die output.txt whether this file is there or not. If it is able to see that file, cat that file, so the success, it is a successful. So it will know that okay, the liveness probe is successful and I don't need to stop the container can stay up and running. So I have to give that. How do I give that? So I give that using exec parameter. Exec will have inside that command, and I have to give cat /tmp/die output.txt. Yeah, so I just want to explain to you. So this is basically, say for example I check something cat tmp/dipesh.txt. For example, if I'm checking this, so it will tell there is no file like /tmp/dipesh.txt. So it is a failure, the command fails. But how do I know the command? How do I know the command fails? So there is something called echo. If you do a dollar and question mark, it will tell the exit value is 1. But if it is, there is something existing, say I create some tmp dipesh.txt, it's already there. So now if I do the same thing, cat tmp dipesh.txt, this is actually successful now. So echo dollar question mark, it is 0, the exit code is 0. So when the command is successful, exit code is 0. Here I am doing, but in this case the kubelet will do this, and it will check this particular file. If it is there, if it is there, it is successful, the liveness probe is successful. If it is not there, the exit code will be not 0 but something else. That means that it is a failure and the container will be stopped. So this is how it works. Now I have provided the liveness probe. I also need to provide readiness probe, and readiness probe is exactly the same as liveness probe. So we are just going to copy 1 2 3 4 5 6 lines. So 6, sorry, escape, 6yy capital P, and here I am just going to give DTP and write readiness probe. Every parameter remains the same, just that exec command I am just going to change it, because what is my readiness probe? I am doing ls/etc. So I am just changing cat as ls, and /etc will be here /etc. That's it. We are good. Now we can see if this, okay, before that let me go back and let me say, something which I forgot to tell you. So readiness probe. So what is the difference between readiness probe and liveness probe? Well, liveness probe actually checks the health of the pod. If it is good, it is fine. If it is not good, it will restart the pod. That is what the liveness probe will do. It will stop and then start. But readiness probe, sometimes what happens, even the pod is healthy, but you cannot allow the traffic inside the pod. Maybe it is not in a position, it also needs some other dependencies to come up or be in sync, so it might take some more time. So you do not want that the traffic should come to the container even though the container is up and running. So for, say for example, you want the initial delay seconds to be more, so you can put here instead of 30 120 seconds. So after 120 seconds the readiness probe will be done. Once it is successful, then only the network traffic can enter the container. So that is a good feature. That is what is readiness probe. I think we have configured all these very nice parameters over here. We have covered a lot of things in this pod, and I just want to check whether this runs or not. Create. Yeah, the pod is created. I want to see if it is generating logs. Yeah, it generates perfectly well the logs and everything. I can check the environment variables also. Exec, using the exec env, all the environment variables should be here. There are some environment variables that are imported in a particular path. We can go there inside the pod and cat those particular paths and values to get those values as well, but it all looks good. So we have also created the readiness probe and the liveness probe, and that's it. So we have designed the pod. Now the pod is completely ready with all these various things that I have shown you. It has the labels, and it has config maps, environment variables, secrets, the resources. It also does some work for you. It rolls a die. Then there is the liveness of the readiness probe. Now there is one thing I also need to do. I have to annotate the pod. So if I want to annotate the pod with my email ID as contact, how do I do that? So I can just get pod. So I will show you quickly how I annotate the pod. Annotate pod dipz22 py. What I have to give, contact is equal to my email ID, contact is equal to dipesh.majumdar@gmail.com. So I have finished annotating the pod as well. Now if I check the definition of the pod, the annotation should also come along with get pod dipz22 py minus o yaml grep annotate should come. So annotation, so let me print another one line after this. Yeah, contact. So the annotations is also coming. So with that we actually have done everything. So we have finished creating this pod from the scratch, and I think you found this video very wonderful. It would have helped you. So I will advise you to practice like this. The more you practice, the better it is for your CKAD exam. The faster you can write these YAML configurations, and the better it is for you, and chances are more that you will crack the examination. Thank you very much. Do subscribe my channel. If you have liked the video, share my video, and thank you, and have a good day. Bye bye.